My name is Virginie Rozot and we are located at the University of Cape Town, South Africa. Briefly, what we're doing is to understand what drives a person to be sick with TB. TB is actually a disease that is transmitted through air and breathing, like COVID. We heard a lot about that recently. And we don't understand why some people get infected and some others will just never be sick, and some people will get very sick. We don't really understand when this happens. We know that people that get infected, for instance, will get sick with a higher chance in the year following infection, but also they might just develop the disease years later without having had any symptoms. We don't understand why these people that never are sick but they are infected are not sick. And so what we're trying to actually do with this study is to look in the organs where the disease happens, and also immune organs, so the body defense system that you have, for instance, the lymph nodes that are these little glands where the army, your army defending your body is starting to plan for the war. We want to understand what's going on there and why actually some people have the right army there and some people don't. And if we understand that, we might be able to develop better tools to avoid people to be sick or even treat them if they become sick. I think if we manage to understand what's going on in the tissues and we figure out what is the trigger, or if we will understand better how the disease develops, we might be able to fight it.
My name is Laura Taylor. I'm a forensic pathologist. My role in the project has been mostly to procure the tissues and facilitate that at the autopsies, but also to give advice on the medical aspects. Lymph node immunology is particularly important because most TB is acquired through inhalation into the lungs, and although there might be initial interactions within the lung parenchyma, bacilli and antigens are then trafficked to regional lymph nodes, and that is where the initial decision making as to whether the disease is going to be contained or whether it's going to progress to overt pathology. So it's really important that these organs are studied at a tissue level, which is where that actually occurs, rather than using proxies like the blood.
My name is Katleho Matlatse. I am the research assistant for the post-mortem study, and today I have our samples that we collected from the mortuary at OFP.
Hi, my name is Tim Reed. I'm a senior scientific officer with SATVI and the flow cytometry core facility manager at the UCT IDM. And the project that I'm looking at is to characterize myeloid cell dysfunction in the tissues and peripheral blood of our post-mortem cases. So the methodology that we're looking at is we've done some flow cytometry, but we're mainly looking at mass cytometry through CyTOF. So we're staining with the 37 marker panel and checking how the cells respond to MTB stimulation versus unstim controls and see what we can decipher from that immune response.
Hi, I'm Dharanidharan Ramamurthy. I also go by Joe. I'm a postdoctoral researcher at the MMRU, and as part of the digital PCR team, our job is to not just quantify MTB, but also try and determine how viable they are or get a molecular proxy for their viability. So we look at the RD9 specifically to quantify MTB. Also for increased sensitivity, we look at the multi-copy gene I6110, and to get a measure of how viable a microbial or MTB population is inside the tissues, that is the lymph node, what we try to do is use the rate of ribosomal synthesis. So we isolate the RNA and quantify the rate of ribosomal synthesis to figure out how alive are these MTB and to what extent do they persist in the lymph nodes.
I am Carly Young-Bailie and I'm a postdoc here at SATVI. I am a postdoctoral researcher on the Wellcome Leap project, and my job is to perform the single cell RNA sequencing on our post-mortem lymph node and blood. And so what we're doing with that is we're trying to find signatures or profiling of the host immune response in people that had evidence of TB as well as healthy people within the project. So to date we have performed 177 autopsies and we've approached 159 families, and 104 of them have consented to participate in the study. So that gives us a consent rate of about 65 to 66%. And so of the people that we perform autopsies, we find that about 20 to 22% of those people had evidence of TB somewhere in their body, in their lungs or anywhere else. But these are the people, in 22% that we find TB pathology, these are people that died from other causes. And so we also perform autopsies on people that were otherwise healthy and we don't see TB pathology or evidence of TB throughout their body, but we do find evidence of MTB nucleic acid in their lymph nodes, and this occurs in about 70% of the people that are otherwise completely healthy with no TB pathology. And so these findings are quite significant because this indicates that there's more people that are infected with MTB than we previously thought. And so when we are looking at the single cell RNA sequencing data, we are trying to find out what the difference is in terms of the immune signatures or the immune response profiles between these people that have TB but they don't seem to get TB pathology versus those that do progress to have TB pathology compared to those who are completely healthy and where we don't find any MTB. This project is incredibly complex and it involves so many different moving parts. We've got a lot of collaborating research groups that do very different things, and so trying to coordinate all these different and multimodal research and multifunctional research within the project has been a really big challenge, but ultimately working towards the goal of creating a very holistic approach to the problem and the project that we've delved into. There are many people to thank for the success of this project, the first being the Wellcome Leap Delta Tissue Program that funded the entire project, as well as the principal investigator, Dr. Virginie Rozot, the entire team, as well as our collaborating research groups, and of course the families of the deceased.